Today we talk about associates. Okay, associates. We also talk about this portion. Okay. Now let R be a let R be a commutative ring with one. Okay, R be a commutative ring with one. Okay, a non-zero element. A non-zero element A belongs to R is said to be associate of a non-zero element B of a non-zero element B belongs to R. Okay, if A equal to BU for some unit U belongs to R. For some unit U belongs to R. Okay, so we also see that A equal to BU where AB belongs to R and U are subunit in R. Okay, so now we write example. Here we know about that in Z set of integers. Okay, 1 and -1 are units. Okay, are units. So for 0 not is equal to A belongs to Z, A and minus A are associates. Okay, associates. We also talk about here we write in this way, that means A is associate of a non-zero element B belongs to R. Okay, in this way we write here, that means B equal to A U inverse. Okay, U is unit, that means U inverse exists, so B is said to be associates of A. Okay, U inverse also exists and U inverse belongs to R. So in this way we give another example in Zi. Okay, in Zi we write here 1 minus 1 I minus I are units. Okay, then what happened? Then thus 1 plus I here minus 1 minus I and minus 1 plus I. Okay, and here plus 1 plus I. Okay, that means 1 plus I, plus 1 minus I. Okay, are associates. Okay, associates of 1 plus I. Here this one A and minus A are associates, and 1 plus I minus 1 minus I minus 1 plus I, and here 1 minus I are associates of 1 plus I. Okay, so we also talk about related one theorem. We write another example, then we also talk about related one theorem. Okay, so in polynomial function, okay, so another example right here. In polynomial function fx, okay, over a field f, over a field f, over a field f, the units are if difference 0, singleton 0. Okay, then we talk about a non-constant polynomial, a non-constant polynomial function fx has ufx for an associate. Okay, for an associate where u belongs to u unit in f, u belongs to this if difference singleton 0. Okay, so we also discuss this associate now. Now we write one theorem related to that topics. Okay, we edit a person and going to discussion one theorem related to that topic. So we write this theorem now. Here, let R be a commutative ring with 1. Let R be a commutative ring with 1. Okay. And ABC belongs to R. Okay. Yeah, and ABC belongs to R. Then what happened? First one. If A is an associate of B, if A is an associate of B, then B is an associate of A, then B is an associate of A. Okay. Next, second, suppose R is an integral domain. Suppose R is an integral domain, then A is associate of B, then A is associate of B if and only if A divided B and B divided A. Okay. Next, we also remove this lower portion or erase this one. Now we write in this way. Suppose R is an integral domain. Then A and B are associate of. Then A and B are associates of each other. Okay, associates of each other if and only A generating set equal to B generating set. Okay, so we also talk about in this way. That means here A divide B, A and B, this one we also see in, that means if A is associate of B, then B is associate of A. And here this one possible, A is associate of B means A divide B, and obviously B is associate of A means B divide A. Easily this one possible. Okay, now we also discuss this one. R is an integral domain, then A, B are associate of each other, then A generating set equal to B generating set. Okay, that means here A equal to BU. Okay, A equal to BU and B equal to A U inverse. Okay, this one possible. Then what happened? Then A divide B and B, A divide B and B divide A, and this implies that this implies what? That means this one happened. Okay, then A belongs to this A generating set, A belongs to B generating set. Okay, that means A equal to B, not a problem at all. Okay, then another way, if this one happened, that means A generating set equal to B generating set, then that means B belongs to this A and A belongs to this B, possible. And this implies that A divided B and B divided A, possible. Okay, so we write in this way. That means this one are possible, so we write A equal to Q1 of B. Okay, and B equal to Q2 of A. Then here B equal to Q2A and here Q2 Q1 B, then this implies Q2 Q1 equal to 1. Okay, then we also, that means see that Q1 and Q2 are units. Okay, this implies Q1 Q2 are units. Okay, units, and this implies that A and B are associate. A and B are associate. Okay, A and B are associates. So not a problem at all. In this way we also discuss this one. Okay, that means first we also see that this one happened, then we also write A B are associate means this one happened, this implies this, this implies this, this implies this, and then this one happened, this reverse this one, this reverse this one, and this one means this one. For q1 q2 are belongs to this r. Okay, then we see that q1 q2 are units, so a b are associate. Okay, so not a problem at all. I think all understand this one easily and suitably. So if you get this type of video, please subscribe my channel, follow my channel, and see this video regularly and click on like options. Today I stop here. Thank you.